This tutorial is about the use of SQLite with App Inventor. We will demonstrate how an app can create and use a new SQLite database. We don't have to start with a database that already exists in the asset folder. We will also show how to develop the complete user interface using a web viewer, HTML5, CSS, and JavaScript. I think this is one of the fastest and most efficient ways of developing commercial apps for Android. The files used in this demonstration can be downloaded as an app from the Google Play Store. For this demonstration, we will create a working diary app. Our diary is going to let us write new entries, edit entries, give a topic to each entry, and display existing entries. All the contents will be stored in an SQLite database. We have to do our planning before we start creating our diary project. Each diary entry will have the diary content, a date and perhaps time as well, a topic such as home, work, sport, study, school, homework, etc. We may want to display the diary by day, next 7 days, next 31 days, by the previous day, previous 7 days, previous 31 days, or input the number of days ahead or in the past we want displayed, or display diary between 2 dates. From these requirements we can work out that the database for our diary will need a single table. Let's call it diary_table. Each diary entry will need a date and time, a topic, and the content of that entry. Each diary entry also needs some aspect that is unique so that we can edit and update an entry and make sure it is saved back to the same row. This might be a value in one column that is always unique, or it could be 2 columns together that always make a unique combination. But if there is nothing that will always be unique, then we can use the row ID to identify the existing diary entry when editing. Each table in SQLite includes the row ID unless we specifically exclude it. When we initialize our app, we need to create this database and table if it doesn't already exist. To create an SQLite database or open the database if it already exists, we simply call SQLite1 Open Database. Then, if not call SQLite table exists table diary table, then call SQLite execute with the SQL statement to create our table. We can use DB Browser for SQLite to create a new database and test the SQL statement that we need. We can use text as the type for all our columns, even for our diary date time column, as we can store values as the text year, month, day, hour, minute, seconds. These values can be sorted using the standard operators equals, less than, greater than, and between. The SQL statement to create this table is create diary table, and then in brackets diary date time, text, topic, text, content, text. We don't need to create the column row ID. This is created automatically. For the user interface for our diary, we will use a web viewer component again. As we saw earlier when editing content, it is much easier to display and edit formatted text when using a web viewer. A web viewer also allows us to make a series of diary entries editable without switching from a display view to an editable view, and we don't need to know in advance how many entries there will be. We will be able to scroll through as many entries as the user selects to display. Previously, we used a combination of App Inventor buttons and boxes as well as the web viewer. This time we will use a single web viewer to complete all of the user interface. It does mean that we will need to make a lot more use of JavaScript. The App Inventor components will control the database and will read and write the web viewer. The protocol that I'm going to use for this transfer from the App Inventor blocks to JavaScript is not exactly the same as we used for the cookery book in the previous tutorial. The web viewer is now in charge and initiates each transaction. The rest of the App Inventor blocks acts as a server that responds to the request. So the web viewer get ~diary, start date, end date. And the server reply ~diary, row ID, and then we'll use our double not symbols to separate diary date, diary time, topic, content. And then we can continue with the row ID, and then the not symbols, diary date, diary time, topic, content, for as many entries as requested. Web viewer put update entry, row ID, column, content, or put and then separated by the new entry, diary date, diary time, topic and content. The server will reply with a message to say saved or a message to say error. The web viewer can send a message, and again all the values separated with this get, search, start date, end date, search topic, search string. And the server will reply in the same format with the separators as before for any diary list of entries. So reply diary row ID separated with the and then the double not symbol separating diary date, diary time, topic, content, followed by as many entries as match the search. All the messages that start with the get indicate a message from the web viewer asking for information from the database. All messages that start with a put indicate a message from the web viewer sending information to be stored in the database. The block components need to process this whenever it changes using when web viewer web view string change, which places the content in the local variable value. All messages that start with reply indicate a message to the web viewer, which will be collected and processed by JavaScript. When we're developing a program that uses the web viewer, it can be useful to display the content of value in a label. Usually displaying the first 100 characters is enough for us to see what is happening, and this first section of code displays the first 100 characters without producing an error if it is less than 100 characters. We now need to code the blocks for the server to respond correctly to each of the messages from the web viewer. Each section follows the same pattern. We check first to see if the value of the web view string starts with a string that indicates the purpose of that message. Then we remove that string by replacing it with nothing. Then we can split the remaining string at the characters to give us a list, and this list will be used as the parameter list for our SQL query. If we were using a web server on the internet, we would have to be a lot more careful checking of values to prevent malicious content being submitted to the server. But as the only access to our app is within the app itself, there is no scope for malicious content. First, we want to display existing diary entries. The web viewer inserts dates into the string get diary start date end date. This matches the pattern get diary . After this pattern is removed, the remaining string becomes start date end date. After splitting at the characters, this gives us a list with two items, start date and end date. The SQL query that we need to extract any diary entries from the database is select row ID, diary date, diary time, topic, content from diary table, where diary date between question mark and question mark, order by diary date ascending, diary time ascending. The part select row ID, diary date, diary time, topic, content from diary table selects the input items that we want. Where diary date between question mark and question mark will only select diary entries that have a value in the column diary date that matches the two parameters that we supply as a list. Order by diary date ascending, diary time ascending, ensures that the order of diary entries is by day and then ordered by the time in that day. The results of this search will be a list of lists. We could process it with list blocks, or we could send the list of lists to the web viewer and process it with JavaScript. I have chosen to convert this to a string and then send the result to the web viewer. Diary entries might contain text with commas or inverted commas, so we cannot just use these to split the string. If we use set SQLite return column names to true, the string will contain patterns of brackets, commas and spaces, as well as the column names that we can identify and use to split the string, and place double tilde characters between diary entries and double not characters between the items in a diary entry. This will construct the message string that the server returns to the web viewer in a format that is easy to split in JavaScript. A new entry for the diary arrives at the server with put double tilde new entry double tilde at the start. So this might be put double tilde new entry double tilde diary date double tilde diary time double tilde topic double tilde content. Removing this pattern gives us diary date, diary time, topic and content, and splitting at the double tilde characters gives us a list with the four parameters, the diary date, diary time, topic and content. The SQL statement is insert into diary table, diary date, diary time, topic, content, values, followed by 4 question marks for the 4 parameters, and this will create a new entry. When we update an entry, the web viewer will send a single value at a time, put double tilde update entry double tilde row ID double tilde column double tilde content. The diary entry that is being updated is identified by the row ID and by the column. This time we need to construct the SQL query to include the name of the column so that the SQL query becomes update diary table set column equals question where row ID equals question. We also have to construct the parameter list to be a list with just 2 values, the first item being the content, the second being the row ID. The web viewer requests a search with the message starting get search start date, end date, search topic, search string. Removing that gives us start date, end date, search topic and search string. Splitting to form a parameter list gives us the start date, end date, search topic, search string as a list. Again we use a select query, and the SQL is select row ID, diary date, diary time, topic, content from diary table where diary date between question mark and topic like question mark and content like question mark, ordered by diary date ascending, diary time ascending. We could search for absolute matches between the search term and what is written in the diary. We cannot always remember exactly what we wrote in the diary. In this situation, it is much better to search for words or phrases that contain the search term. For example, we're searching for app, would find a phrase containing App Inventor and My Appointment. To achieve this, we add the % character to each end of our search term. So instead of the parameter being simply app, it becomes %app%. For the parameter for the topic like question mark, the web viewer can send a value of just a pair of % characters for this parameter, which means that it will match any item in the topic column. %t% would match any topic that contains a T. %appointment% would only match a topic column that contains the word appointment. And content like question mark parameter, the web viewer can send a value of %% for this parameter, which means again that any item in the content column would match. %t% would match any content column that contains a T, and %appointments% would only match a content column that contains the word appointment somewhere in the text. The results of the search are processed in exactly the same way as the get diary request, so we could use a function for that code and code it only once. That is all the blocks that we need to create our app using App Inventor. The rest of the code we will write in HTML and JavaScript. To follow this next section, you will need some knowledge of HTML and JavaScript. Have a look at my tutorials on writing web pages first for a quick introduction. The code for the web viewer is an HTML page with some CSS and some JavaScript that we upload to the assets folder. We will call this HTML page diarypage.html. The home page for the web viewer needs to be set to this file. file:/android_asset/diarypage.html. This page will also use some JavaScript code known as jQuery, and we will upload two jQuery files to the assets folder. These are jQuery.min.js and jQuery-ui.js. We will also use moment.min.js, which is another JavaScript code file that makes handling dates and times a lot easier. Also upload that to the assets folder. The web view page can be designed and developed with just a text editor and viewed and tested in a web browser. It can be designed using a static example of the data that would be sent from the server. Only when it all works with static data should you switch to the dynamic data from the server. When you view your developing page in a browser, select the tools to display the console log. This reports any errors in our JavaScript code, and we also use it to display the messages sent to the server using the console log. The code for the HTML page starts with the standard HTML5 headers. Styles could be placed in a separate CSS file uploaded to the assets folder and linked from the head of this page. Each diary entry is placed in a section element and given a border. The top menu and bottom menu have a yellow background and a margin round them to give space to the buttons they contain. Buttons are also given a margin and rounded corners. The size of the text area is set here so that it responds to the width of the device. Note how the code is a series of divs, each of which has its own ID and each with a separate function. These divs are hidden until needed when the app is running, but when you are developing the code, start by displaying them all. The form for entering new data. This shows some static content here, useful when first designing the app. This can be replaced by dynamic content to insert the date today when the app is run. This form is only displayed when new entry is selected. The form used to perform a search. Again, this form is only displayed when search is selected. The diary content contains some static examples of diary entries used in code development when not connected to the server blocks. When the app is run, these examples are replaced by real diary entries. We load the JavaScript libraries from the Assets folder, or when testing, from the same folder as the HTML file. Now we need to examine the JavaScript code that creates our dynamic app. We start by initializing any global variables. There are several places where we want to insert today's date in a form. These are identified by the class newDate. We loop through each in turn and insert the value of date today into the form. The console log allows us to see what is happening during initial testing in a web browser. We need to set a timer that calls the function checkMessages to check for new messages from the server at regular intervals. In JavaScript, we can use / for comments or code we don't want to run. This is the function that runs at regular intervals to check for new messages from the server. We can also use it to update the day and time. We check that we are connected to the App Inventor server before testing for messages from the server. We set our variable page text to contain the string from the server and check it starts with the text reply, otherwise ignore it. And then we reset the web view string so that we don't read it again at the next time interval. We check to see which message has been sent and then call the appropriate function to respond to that message. Notice how we are using the same process here as we used with the blocks on the server to handle message. Replace the part of the string that identifies the message, leaving us with the body of the message. Then we split the content at the tilde characters into an array. Next we start to build the dynamic HTML code that will be displayed and updated every time the display of the diary is changed. The first part of the code here produces buttons that give quick access to the contents of the diary. Then we check that the message string from the server actually contains a diary entry before we extract the entries for display. An entry must contain the " characters. Then we go through our array of entries and split the string for that diary entry at the " characters to separate the individual items that make up the diary entry. We split this line into an array and then, to make it easier to read, set a variable for each item in the array. Then we insert the text for each item from the server into the HTML code that creates each diary entry and make it editable. The variables are inserted where you see the plus variable name plus. Each diary entry gets added to the HTML text. Note how the row ID variable is added to each ID so that each item has a unique ID. Notice also that we write data items into the HTML code to use when the item is edited. Finally, we add the dynamic bottom menu to the HTML text. The HTML text we have assembled is now inserted into the div identified with the ID page display. The page display is now made visible and other options are hidden. Next, we must call the function updateFocus, which ensures that the new HTML elements are detected when the user edits them. When the user selects a new diary entry, the form is created dynamically so that the current date can be inserted. It is then written to the div with the ID new_diary_entry and displayed. The code for the search form is not dynamic, so we only display the div that contains the form and hide other divs when the user selects a search. The form to submit a new diary entry calls the function newEntry and sends the variable for the form when the user taps the submit button. The button sends the ID of the form to this function. The values that have been entered into each element of the form are then collected by this script from the form and assigned to variables. We want to be sure that the user hasn't typed either tilde or not characters, so we simply delete these. And now create the string that we can send back to the server from these variables and our separator characters. And if we are running in an app, send the message to our server. Then we send the previous request to display the diary, which we stored as the variable last request. This will update the display to include the new entry the user has just added to the diary. The search form submit button calls the search diary function and sends it the ID of the form. The values that have been entered into each element of the form are then collected by this script from the form and assigned to variables. Again, we want to be sure the user hasn't typed either tilde or not characters, so again we will simply delete them. We now create the string that we send back to the server using these variables and our separator characters. Notice how we are adding the % characters to enclose the values used in our search that we discussed when we looked at the blocks on the server. And if we are running in an app, we send the message to our server. The menus have a series of buttons to make it easy to select groups of diary entries by date. These buttons call the display diary function. This function then uses the moment library to calculate the dates that we need in the messages that we send to the server. So the message is created and sent to the server. The function update focus ensures that the focus out event works on new content that we have added dynamically. The focus out function detects any time the user has selected an HTML element that has the class div edit and then removes that focus. We assume that the user has edited the content of that item, and we use the ID of that item to save the edited content. We read the column and row ID from that HTML element identified by its ID. We get the HTML content if it is the topic or the text content of the diary entry, or we get the value of the date or time from the date picker form. Again, we want to be sure that the user hasn't typed either the tilde or not characters, and again we simply delete these. We assemble the string to send to the server, and if we're running as an app, send it to the App Inventor server. And that is the end of our JavaScript functions. The next 2 lines of code run when the script is first run to display the next 7 days of diary entries and to update focus so that the entries are editable. When developing the server blocks, I make a note of the SQL queries here as comments. This helps coordinate both server blocks and the web page.